Starting from here, we'll focus our discussion mainly on the packet-switched internet. And 1.4 is to talk about the important metrics we care about designing protocols for it. That includes delay, loss, and something called throughput, which we'll talk about at the very end of 1.4. How do loss and delay occur? Well, let me draw your attention to the example below. That'll be easier. First kind of delay is happening here in the packet that is going out, being transmitted out. That delay the packet is experiencing is called the transmission delay. That is the time it takes to transmit the packet, and we know how to calculate, don't we? It's packet size divided by the link rate. But there's a second kind of delay experienced by packets here before they get to go out. These are what? Packets waiting in a queue, waiting for its turn. And how can there be packets waiting in a queue? It actually happens quite often when the incoming rate exceeds the outgoing rate. So you see in the example, A and B sending packets actively together into the router. In case the aggregated arrival rate is higher than the outgoing rate here, then you will see there will be always packet here waiting to be transmitted, and therefore subsequent packets will need to what? Wait up. And that is queuing delay these packets are experiencing. Now the calculation of queuing delay is a lot more challenging than the transmission delay. It really depends on the arrival pattern before a packet comes into the queue. Okay, now if that pattern is reoccurring, predictable, then it will be easier to calculate this. Otherwise, very challenging. Now, that explains packet delays, where they might occur. Packet might get lost as well at the router, and it happens here. Focus on this thing here. It's the packet queue. The size of the packet queue is limited. Okay. By the way, that packet queue is also often referred to as the buffer. Okay. And the buffer space is limited, just like the memory space is limited. The buffer space is just a way of calling the memory reserved, okay, to store these packets. Now, given that the amount is limited, in case congestion persists for a long time, then eventually you run into the situation. There's no longer free buffer space in the queue. In that case, arriving packets will get dropped, and therefore we see packet losses.